Okay, hello everyone, welcome back again. So today we are going to discuss about hardware description language. Okay, so you can understand by the name, the language that can describe the digital hardware, like different type of control circuit or logic circuit. Okay, so since when we use a logic circuit, first we have to implement on our breadboard and then experiment with some input data, and then we can verify whether our program or whether our circuit is all right or not. Okay, so a number of complexity arise. Sometime there we got some loose connection on the circuit, or sometimes some IC doesn't work properly. Sometime we got high voltage and our circuit burns out. That happened to us a number of times. Okay, so this thing happened. But if we can simulate first by a software, then it will be less expensive, and it will be more comfortable for us, and we'll be able to find, or we'll be able to see whether the input is working properly or not, or whether the circuit is working properly or not. So that's why to describe the hardware, the language is called hardware description language. Okay. So, what is hardware description language? You can see here, basic idea is a programming language to describe the hardware. Initial purpose was to allow abstract design and simulation. Design could be verified and implemented in the hardware, as I told you. The initial idea was just for simulating, okay? But nowadays, the code can be directly copied to the FPGA, okay, or field programmable gate array circuit, okay, we are going to discuss about FPGA in some other lecture, okay? So, now synthesized tools allow direct implementation from HDL code. Okay, that is the most interesting part. Okay. So, the issue is write, run, debug, just like our high-level language, like C or Java. Okay, first we write the program, we debug the program, we run the program, which is very simple. Then the hardware issues, like for hardware, what we do? Design, implement, debug. Okay, first we design the logic circuit, then we implement on the breadboard, and then we debug it by using some input and watching the output. Okay, so HDL is much faster and much easier to implement, okay, and of course, as I told you, less expensive. So as I told you on last slide, combined with modern FPGA chip for large complex circuit, okay, by using this HDL program. So let us see what kind of HDLs are there. A number of HDLs are there. One is Verilog HDL, one is Abel, another one is VHDL. So we are going to, VHDL means VHSIC, hardware description language. And what does it mean by VHSIC? Very high speed integrated circuit. Okay, so if you combine all these things together, it becomes VHDL. Okay, but in this session, we are going to discuss about Verilog HDL, which is actually the second most common language. It's just like C-type syntax and better for teaching. That's why we choose it. And you can see here the history. It is they developed on 1985 and then came to public domain on 1990 and got the IEEE standard on 1995. Now let us start the real issue. How a programming language can discuss this kind of logic circuit. You can see here there are three gates. One is AND gate, one is OR gate, another one is NOT gate. Okay, we have given three names for these three gates. For AND gate we have given G1, for OR gate we have given G3, and for NOT gate we have given the name G2. Okay, and in this circuit you can see we have three input A, B, C, and we have two outputs X and Y. There are some internal connections One is from G1 to G3, which is described by E. Okay, or just name the connection as E. And another connection is there with G2 to G3, but we didn't give any name. Why? Because this is the same connection of the output Y. Okay, so that's why we didn't give any other new name for this connection. So this is our circuit. To write corresponding HDL code for this circuit, we have to maintain some syntax or how to say, the way, or we have to use some keyword, okay, for implementing this thing. So one important keyword is module. Okay, so we have to start the word module, like some other languages. In C we used void main, this kind of things, but here we have to start with module keyword, and then we will discuss input and output, and then we are going to discuss all the gates used in this logic circuit. Take a look the corresponding code here. Like this is started with the keyword module, then the name of this circuit or name of this project or name of this just logic circuit is simple circuit, where we have to include the input and output we are going to use in this logic circuit, which is A, B, C as input and X, Y as output. Okay, so after initializing, then we have to declare the input, outputs and internal connections. So to declare the input, we use input keyword. To declare the output, we use output keyword. And to declare the internal connections, which actually can be declared by where keyword. Okay, once again, where keyword is using for internal connections. Okay, you can see here in our circuit, we have three inputs A, B, C, two outputs X and Y, and our internal connection E. Now, how we can describe the gates? You can see here, just write the name. For AND gate, just write the name and then the name of the gate G1, and important thing is first you have to write the name of output. Okay, output variable. So for G1, the output is E and then the inputs A and B. Done, and it will finish with a semicolon. The same thing will happen for another gate, NOT gate, and also the same thing happen for OR gate. Okay, so you can see here the program, like start with module, then declaration, input, output, and where, and then the description of all the gates used in this circuit, like AND gate, NOT gate, OR gate, etc. Okay, so and of course it will finish with the keyword in module, and there will be no semicolon after the module keyword. So it's discussed in next slide here. As I told you, just one new thing is here. We can give the comment by using double slash. Okay, and everything is discussed here. Now another important issue we can use here. Another important issue means every electronic circuit or digital logic circuit have some delay, or you can call it propagation delay. Okay, propagation delay means when input came to our gate, like I have given 1 and 1, it will certainly generate output 1, but from this point to this point, it have to trigger some transistors inside it. There are some transistor circuit. So for triggering every transistor, it requires some amount of time or some, so we'll get some delay from this input to this output. There is a delay. A very small amount of time is required for it. Okay, this time is called propagation delay. Okay, so interesting thing is we can use this propagation delay inside our HDL code. Okay, this is very simple. Okay, very simple. We just need to mention the delay between the type of gate and the gate name. So we can just rewrite here AND gate, then special symbol hash symbol, then the delay in first bracket, like if we use 30 nanosecond for G1, then in the first bracket we will write the delay. Okay, so that means this AND gate requires 30 nanosecond, and the unit is nanosecond. Whatever I write here, this is the unit in unit nanosecond. So it requires 30 nanosecond to trigger this, or we can say to get the output for this gate. That means if we will give 1 on 20 nanosecond, we will get this output on which nanosecond? 50 nanosecond. You understand? So that is called propagation delay. So we can use this propagation delay inside our HDL program, which is very interesting, because if you cannot calculate the propagation delay, you cannot calculate the speed of your computer or speed of your digital logic circuit. Okay, so identify the speed, or to measure the speed or how these things is working, to know this characteristic, the propagation delay, inclination of propagation delay is important. Okay, so you can see here in this code, you can see here for AND gate 30 nanosecond, for OR gate 20 nanosecond, and for NOT gate 10 nanosecond.